Hello everyone, this is Ehsan. In this video we are going to create a table which shows, so basically a conversion table showing the corresponding value of a Celsius for a certain degree of Fahrenheit. And the idea is inspired from a very practical problem. So in the United States of America, international students face a lot of trouble understanding the Fahrenheit scale because they're usually accustomed to Celsius back at home. So that is the reason we are going to create this conversion chart. And the way we create it is, or the way we solve this problem is using a certain software engineering paradigm, which is called top-down design, where we somehow decompose the problem into small parts and go to that small part and further, if required, decompose it and gradually solve the whole problem, which is creating the conversion table or chart. So for this, what we first need to do is we want to get the limits of our table. So what will be the lowest value that we are from which we are going to start computing this Fahrenheit to Celsius conversion, and what is the highest value up till which we are going to do this conversion. And then there is also design consideration, is how much increment we will do for each. What will be the how many values do you want to compute in between these things? So what will be the increment in this table? So if the lowest limit is 40, do we want to compute the next one, which will be 40 minus 40, sorry, 40. If it's 40, then it will be 45, or whether we want to compute 41 degree Fahrenheit to Celsius. So these are some things that we have to take into consideration. So let's start this thing. So let's first define the limits. Since this limits will be constant throughout this entire program, we want to write it in a way that it remains constant and no one in the middle of the program can change it intentionally or unintentionally. And the way we do it we say const, and since these are integers, we say int. Usually constants are defined using all capitals, so we say lower limit. Let's say it starts from minus 40 degree Fahrenheit. And then we say the upper limit is similarly const integer upper limit, and it will be, let's say, 1000. And then this upper limit and lower limit is set, and this number cannot be changed throughout this entire code, intentionally or unintentionally. So first we want to do is display the table title. So let's for that we directly say display table title, and you instantly think, is there a function in C++ which does this? And we say no, we don't have anything. But don't worry, we are going to create it because we know how to create functions. So this is kind of the top-down design idea, that you directly work at the idea level and not directly at the code level. So what we can understand is display table title will basically take no input because it is a constant idea representation, and it will basically not return anything because it will just display something at the console. And then what we do is we say create Fahrenheit to Celsius chart, or we can say get limits and create Fahrenheit to Celsius chart. Here we need to get the limits. So let's say we put these two things, upper limit and lower limit and upper limit. So what it does is basically it takes the lower limit and the upper limit from the constant values and computes the corresponding Celsius values in appropriate way, which we will discuss a little later, and just display them. So they will basically not return anything that we can use because it is just being displayed at the console. So now this is kind of top-down design, so you're directly working with the idea. I'm stressing it again. So let's go and first create this one. So we have decomposed this problem into two parts: create table title and get limits and create Fahrenheit to Celsius chart. And then let's work with the first part of the problem, which is display table title. As we know, it takes nothing as input, so it's void, and it returns a void. So it will just do a display, and the usual display in a console is using cout, console out, less than the stream insertion operator, and we say, let's say Fahrenheit, and we make it capital, we create a F over here, then we want to put some spaces in between. What we could do this, but we can better do something better. We say back /t, which is a tab, /t, which is a tab, /t, that's another tab. So 3 tabs away there will be Celsius. So we write, copy this, we paste this, change F to C, and we say Celsius, SIUS, and then we do endl. So and as we know, it returns nothing. You could just keep it this way, or if you want, you could do return. Both are fine, because here return is basically returning nothing. Then we go to this part of the problem, and we are going to create the function for this, and we say, since this does not take anything as input, we say void, and we put the lower limit would be, so let's say int, because it's taking 2 integers and displaying the chart. So we say lower limit, and we say int upper limit, and we open brace, close brace, and since it doesn't return anything, we can just do return, and we'll have to write some code in between. But the beautiful part of this thing is we can directly test the code right now. And you might say, what will happen? Well, basically it will just print this, because initially at main this gets executed and this returns nothing, although it takes 2 inputs. So let's run this and see if it's working. So just to test, this way you can basically test if your software structure or your program structure is well defined. And that's the beauty of top-down design. You can instantly write code and check if your basic architecture is working nicely or not. So let's do build and run. You see, it works. We have put how many tabs? 3 tabs. We have put 3 tabs here. Nice. Now let's go and create this table. Using the upper limit and the lower limit, we will compute all the intermediate values at a certain increment, with a certain increment, which will be displayed here sequentially. So from -40 to 1000, including 1000. So, okay. So let's close this window and get to work. We are going to create this part of the problem. We are going to solve this part of the problem. So here, since we know the lower limit and the upper limit, we know how many times we want to, what are the limits, so we can use a for loop. So we can write for int lower limit. So we can say L limit is equal to this. So we initialize our for loop. We say that it has to be less than or equal to the upper limit. So we say lower limit is less than or equal to the upper limit, and then we provide the increment at which the lower limit changes. So what we do is we take this, and initially let's say that the increment goes 1 by 1, and within the body of this for loop we calculate the Celsius to Fahrenheit conversion. So let's decompose this thing again using top-down fashion. So what we want to do is we want to basically take the Fahrenheit and compute its corresponding Celsius value. So compute, let's say we call the function compute Celsius from Fahrenheit. Where is Fahrenheit? We save this. And we understand that this will basically take L limit as input, which is an integer. So it will take L limit as input, and it will actually compute a double or a float, a real number, because although the limit is in integer, or the value is in integer, the corresponding Celsius value can be certainly something which is a real number and not a integer. So we want to provide input as integer and get an output as a double or a float. Let's say for higher precision we keep it float. So we say double Celsius is equal to this. And then what we want to do is we want to print this. We want to do cout a limit for the Fahrenheit. We place 4 tabs, which will be let's copy 3 tabs. Let's copy all these 3 things, and then let's put the corresponding Celsius value, and we put it this way. Now, so you see, this is top-down design. You initialize your for loop using the lower limit. You increment the for loop 1 by 1, and you increment up till the upper limit, including the upper limit. And then for each lower limit value that you get, which is basically a Fahrenheit value, you compute the corresponding Celsius, save it as Celsius, and then you basically print the value sequentially, and you need to put an end L over here, end of line. So here maybe a better thing would be not to use lower limit, but say that this is actually Fahrenheit. So let's say, because that way the name is clear. So this is not lower limit but Fahrenheit, so it's a Fahrenheit value. We change this to Fahrenheit. We change this to Fahrenheit. This is a better name, better variable name. So we change this to Fahrenheit. We change this to FAHR, and we call it Celsius, and then we say it's FAHR, and we call it Celsius. So basically what I wanted to say was lower limit is initial. So your for loop is initialized with a variable called Fahrenheit, which is in short far, which initializes with the lower limit value and gradually increments to the upper limit. And now we have to compute this part. We don't have a function for this, so we need to write a function for this, and let's keep it here. So let's say it's not void, so we say compute this. It takes in an integer, so we say it's Fahrenheit. It takes a Fahrenheit value and it returns a double. So it returns a double. And say for instance, let's put it return 0. So whatever value you give, it always returns 0.0. And let's check whether this code is working. Control R. And you see, using top-down design, we can instantly check our code that for whatever value, Fahrenheit value we have, it is 0, because we are actually not computing the actual Celsius value. And you see there is a tab missing. Maybe it's for some purpose we are not going to explain here. We'll talk about this later. So what we could do is we could just put another tab. Let's put another tab and run it again. and see if it works. And it is almost done, and we check the thing. Now it's working nice. Now we need to somehow compute this thing. So let's go to Google and see what is the formula for computing Fahrenheit. So what is the formula for computing Celsius from Fahrenheit? We go to Fahrenheit and it says deduct 32 and then multiply by 5 and divide by 9. So what we do is we go to Qt, we put a brace like this and we say reference, because we're taking it from one website, let's give them proper appreciation. We copy the link, we go to Qt, we put the reference here. It's a weird link, but that's okay. Then what we do is we compute the Celsius value for this particular Fahrenheit here. And we do this like this. We say that double Celsius is equal to, so deduct 32 from Fahrenheit. We deduct 32 from Fahrenheit. And then what we do is we multiply it by 5 and divide 5.0. We deduct the whole thing by 9.0. Or we could have done it a little differently. We could have done like this. A cleaner approach would be removing all this and doing this. It's all the same. And now we return Celsius, not 00. Celsius, and that should work. Let's try it. Control R. Nice. For 1000 degree Fahrenheit, we get 537 degrees Celsius. Can I check that here? Let's see. For 1000 degree Fahrenheit, let's see, where is the table? Sorry, it's here. For 1000 degree Fahrenheit, we get exactly what we computed. So this is how you can use top-down design to create programs which looks really nice, and this is the approach that you should take to all your problems. Just to add, the final thing that remains is basically putting appropriate comments. So here I have put comments for the constants, then I have put comments for the display table, which says the description of the function. It gives says that the input is not, you don't give anything as input, the output you expect nothing as the output. And you can actually write like this, so you can say function name, and you can copy this here. It's very good style of doing software engineering. And you can say usage, how do you use it? You say you just do this. Usage is like this. This, because it takes nothing, it displays nothing, outputs nothing. So anything else that I wanted to add here? No. So then you do the same for compute Celsius from Fahrenheit. Here I made a mistake with C, it should be S, but that's okay, I guess. Then you do the same with get limits and create forward Fahrenheit to Celsius chart, and that's it. And just for one last time, we run it, and well, it says save first. I save it, we run it. Okay, and it works. Thank you guys.